Hey folks, I'm Mr. Hartzler, and I want to talk to you today about common logs. Common log has base 10, and because of that, we know then that log base 10 of x is just going to be log x. Because that's the common log, we use it so frequently, people get annoyed at writing the 10, so we really just don't write it anymore. So that's all that is. The common log means if there's no base, you assume that it's base 10. Let's work on some problems that relate to these. So we're going to solve these exponential equations using logs. We do that by trying to get our x out of our exponent first. So to do that, I have to know my properties of logs, and one of them is the power property, which means that if I have a log and I have a variable inside or a number inside raised to something, I can bring that down in front. So I start off by bringing logs in for both of these. Now that I have that, I can take that exponent down in front. So I have x log 3 equals log 15. Again, I'm not going to write any base because I'm going to use the common log. That's easier. It's just less writing for me, so why not? And we used here power property. Now I need to solve for x, and you should know that log of 3 is just a number. We could find that by typing it into our calculator, but we can just divide by it just like any old number. And because of that, I now have x equals log 15 of log 3. My students complain, but if I didn't give them a calculator, I'd be fine with this as my answer. And I do want to note that log 15 divided by log 3 is not log of 5. It doesn't work that way. We actually have to find out what log of 15 is, then divide by what log of 3 is. If we do that, we end up with about 2.465. I say about because we have to do some rounding to make that happen. Next, let's do the one over to the right here, and that is 4 raised to the x equals 12. Again, I'm going to bring in a log on both sides. Because of that, my exponent can now come down in front, so I have x log 4 equals log 12. I divide by log 4, just like if it were a number. So now x equals log 12 over log 4. Again, that does not equal log 3. That's not how that works. But if I do a little bit of typing into my calculator, I find out that this is about 1.792. Again, it's the common log, so I don't have to do anything weird at my calculator. It's all pretty typical. Let's go on to our next one, which is 3 raised to the 2x is greater than or equal to 6 raised to the x minus 1. So it gets a little bit more complicated. Actually, I have to zoom out because we have a lot of work to do in this one. First, I need my variable out of my exponent. To do that, I need to introduce log on both sides. So I have a log here. I have a log over here. That means my exponents can come down in front. So now I have 2x log 3 must be greater than or equal to, and now it's going to be x plus 1 of log 6. Now keep in mind, x plus 1 is all an exponent, so now it's all down in front, still being multiplied to all of this log 6. So I will have to do some distribution there. And again, I used power property in the beginning. That's an important piece. We use that a lot. So I distribute this log 6 in, and I have log x times log 6 plus 1 times log 6, but I don't have to write that 1. It's assumed. Now get everything with an x to the left. This is just like normal everyday algebra. I'm going to subtract x log 6 to both sides so that now it shows up on my left. I have 2x log 3 minus x log 6 is greater than or equal to log 6. Again, this log 3, log 6, and log 6, they're just numbers. Okay, if it were 2x times 3, you wouldn't be any more mystified than you are with this. So just don't think of it as anything too scary. Now I have two terms on my left. Both have x involved. I don't like that. It looks kind of weird right now. I can't really add or subtract things too well. So I'm going to factor out an x. When I do that, I am left with this. My right side is unchanged. Now I can simplify this chunk now or later. I'm going to do it later because I'd rather just pick up my calculator once if I can help it. So I'm going to divide by 2 log 3 minus log 6 on both sides. I don't want to write it twice, so I'm just going to do the little line right there right now. And then I have x on the left is greater than or equal to log 6 over 2 log 3 minus log 6. Keep in mind, or remember here, if we divide by a negative with an inequality, we have to flip this sign. I'll tell you right now that this is positive, so we don't have to worry about that. But we type all of this into our calculator, and we get that x must be greater than or equal to about 4.419. All right, go on to our next one, and really this is an example as it is just a definition. So for change of base formula, that's if we have a base maybe of 3, but we'd rather have it be a 10. 10 is nice because, again, our calculators are super easy to type it in that way. So we have this formula that we can use to change that around. So as an example, let's look at this one. Log base 3 of 20. Well, again, I don't like base 3. I'd rather have base 10. So that means I can have log base 10 of 20, that inside piece, divided by log base 10 of 3, our little base on the original part. And again, this is nice because we don't even have to write that 10. So just like down here, and our calculator uses this super easy. We can do this other one in the calculator, but it takes a little bit of work. We have to go through the menu settings. It's not so fun. This one, a whole lot easier. Alrighty, hopefully this video was helpful. If it was, please click that like button down below, and I will put links to my next videos up over here once they're ready. Have a great day, everybody.